Hello everyone. Again, I'm coming with physics numericals. Okay, so exercise chapter 8, current electricity in that exercise C. Okay, so this is the first question, numericals we are going to discuss. Okay, so question number 1, an electric bulb of resistance 500 ohm draws current 0.4 ampere from the source. Calculate the power of bulb and potential difference at its ends. Okay, so the resistance is given as 500 ohm and current is given as 0.4 ampere and power we need to find out. So by Ohm's law, V equal to IR. Okay, so substituting the values in the formula, we will get it as 0.4 times 500, that is 200 volt. Then we have power, the formula is P equal to VI. So the value of V is 200, I is 0.4. So 200 times 0.4, that is 80 watt. So power is 80 watt and the potential difference at its end is 200 volt. Okay. Yeah. Next is question number 2. A current of 3 ampere is passed through a coil of resistance 75 ohm for 2 minutes. How much heat energy is produced and how much charge is passed through the resistance? Okay, so a current of 3 ampere is passed through a coil of resistance 75 ohm for 2 minutes. How much heat energy is produced and what is the charge? How much charge is passed through the resistance? So what are the given conditions? We can write it down. So current I is 3 ampere and resistance R is 75 ohm and time T is 2 minutes, that is 120 seconds. Then heat produced. So using the formula H equal to I square RT. So I is 3. So 3 square times 75 times 120, that is 81,000 joule. That is the heat energy produced. Okay. Next is charge. Charge passed through the resistance. So charge is equal to current times time. Okay. So I times T. So substituting the values of I and T, we can we will get it as 360 coulomb. Okay, so the charge passed through the resistance is 360 coulomb. Okay, it's a direct formula, direct application only. Okay, so just you should understand the question and what are the given conditions. You should be able to write it down, and using that formula we need to remember and substitute that one. So heat energy liberated, heat energy produced, that is H is equal to I square RT. Then charge is always current is charged by time, so charge will be current times time. That is the main point you need to remember. Okay, next is question number 3. Calculate the current through a 6 watt lamp rated for 250 volt. If the line voltage falls to 200 volt, how is the power consumed by the lamp affected? Okay, so what are the 60 watt? That is power is 60 watt and voltage is 250 volt. Okay, so we know, substitute the values and current we can find out. I we can find out. So 60 divided by 250, that is 0.24 ampere. Okay, then power consumed when voltage is 200 volt. That is what the question. If the voltage become 200 volt, what will be the power consumed? That is what we need to find out. Okay, so resistance will be V square by P. So the resistance of the appliance will not change, right? So lamp, resistance of the lamp will not change. So resistance we are finding using the formula V square by P. So applying that, we will get resistance as 1041.6. Otherwise, another proportional method also we can apply. V square by P will be same. Resistance is same. No, so you don't want to find out resistance. So you can use resistance will be same. So that formula we can apply using proportion. In mathematics we already studied. No, so if the ratios are equal, we can equate that to ratio. So V square by P formula you apply it. So 250 means the power is 60. 200 means the power we don't know. Okay, so 250 whole square divided by 60 is equal to 200 square by P we can apply. Okay, then cross multiplying times we will get the value of P. Okay, so that is also easy for doing. So in this case, they calculated what is V square by P, that is resistance. Then that one again we are substituting in the another value. V become 200. So what will be P? So V and P may change according to the voltage power will be say, different. But the resistance of the electrical appliance will be same, right? So that is why the resistance we have equated. So resistance we got it, and the resistance will be same for a lamp. So that is what we have considered here. So V square by P is same. So when V become 250, P become 60. Then V become 200, P we don't know. So first case R we got it. That R we have substituted in the second value. Okay, so by calculation we will get the power consumed reduces to 38.4 watt. Okay. Now question number 4. An electric bulb is rated 100 watt 250 volt. How much current will the bulb draw if connected to a 250 volt supply? Okay, so first case, if the voltage is 250 watt, the power will be 100 watt. 250 volt means 100 watt. Then they're asking how much current will the bulb draw if it is connected to 250 volt. So current we need to find out. Clear? Power given, voltage given. So power is equal to V times I. So from that I we can calculate. Okay, so we can substitute power as 100, voltage as 250. So 100 by 250 will be 0.4. So 0.4 ampere. Okay, now question number 5. An electric bulb is rated 220 volt and 100 watt. What is the resistance and what is the safe current can be passed through it? Okay, so using potential difference and power. So just now we have discussed, no, the power is V square by R. So using that formula, we will get the value of R. Here we got it as 484 ohm. Then using R, otherwise P is equal to VI formula is enough for finding current also. So current I is equal to P by V. So 0.45 ampere. Okay, now question number 6. A bulb of power 60 watt is used for 12.5 hour each day for 30 days. Calculate the electrical energy consumed. So this is what actual what is it application in our life. So electricity bill and all they are calculating use this method only. So power is 60 watt and time is 12.5 hours for 30 days. So energy will be calculated by power into time. So 750 watt hour. Okay, for one day. So like that 30 days means what you wanted to do? That one multiply by 30. So 22,500 watt hour. Watt hour, that short form. We need to write the answer in short form. So divided by 1000 means it will become kilowatt hour. So 22.5 kilowatt hour will be the total electrical energy consumed in 30 days. Okay, now question number 7. An electric press is rated 750 watt 230 volt. Calculate the electrical energy consumed by the press in 16 hours. Okay, so the power given time is 16 hours and the first case electrical energy. Electrical energy is power into time. So here 16 hours. So what? Power is in watt. So the answer will be in watt hour. So it become a big number, big 5-digit number. So divided by 1000 means 12 kilowatt hour is the total electrical energy consumed. Okay, now question number 8. An electrical appliance having a resistance of 200 ohm is operated at 200 volt. Calculate the energy consumed by the appliance in 5 minutes in joule in kilowatt hour. So, electrical energy. So, first of all, power we need to find out. Power into time is okay. Otherwise, many formula are there, no. So, that formula we need to remember. V square T by R. So, resistance given, potential difference given, time 5 minutes. We need to convert into seconds. So, it become 300 seconds. So, Total answer that V as 200 square, then T as 300 and R as 200. So we will get 60,000 joule. 60,000 will be the answer, but all are in SI unit, right? So the energy unit will be in joule. Now what is in kilowatt hour we need to convert. So 1 kilowatt hour we know 3.6 times 10 to the power 6 joule. So 1 joule will be 1 divided by 3.6 times 10 to the power 6. So 60,000 unitary method in mathematics that you need to remember. So 60,000 joule means how many kilowatt hour? That one multiply by 60,000. So 60,000 divided by 3.6 times 10 to the power 6. So 10 to the power 6 means 6 zeros. Okay. So already one decimal point is there. So 36 and 5 zeros will come. So when we divide that division, you have to do no other excuses. You have to do using long division method. Okay. You may feel like that division, the big number will be, ayo, how much? A big number how to divide, that is actually big more number of digits means it is very easy only actually, because only one time or two times we need to multiply and check it. One decimal point only we need to make, no, so it will be easy only actually. Okay, so the answer is 0.0167 kilowatt hour. Okay, now question number 9. A bulb rated 12 volt 24 watt operates on a 12 volt battery for 20 minutes. Calculate the current flowing through it and the energy consumed. So potential difference is 12 volt, power is 24 watt and current we need to find out. So power is equal to V into I. So I will be 2 ampere. Okay, that is first part over. Now next is energy. Energy is power times time. P into T. So power time is 20 minutes. That is 1200 second. So power is in watt. So 24 times 1200. That is 28,800 joule. That much heat energy is consumed here. Okay, now question number 10. A current of 0.2 ampere flows through a wire whose ends are at a potential difference of 20 volt. Calculate the resistance heat energy in 1 minute. So current is 0.2 ampere and potential difference is 20 volt. So by Ohm's law, R we can find out using the formula V equal to IR. So R is V by I. So 20 divided by 0.2. So 100 ohm will get. So first one's answer we got. Now heat energy produced in 1 minute. 1 minute is same as 60 seconds. So heat energy produced will be equal to I square RT. That is I square is 0.2 square times 100 times 60. That is 240 joule. Okay. Just you should remember how many times I told that heat energy formula. Many times I read it, no? So automatically it will be familiar to you. H is I square RT or V square by R into T. Okay, like that you should have to remember. While doing the problem only, you will be familiar with that formula. Okay, so one time reading and going, you won't get it. We have that much memory only. Okay, human beings have memory, that much memory only. Okay, so question number 11. What is the resistance under normal working conditions of an electric lamp rated 240 volt and 60 watt? If two such lamps are connected in series across a 240 volt main supply, explain why each one appears less bright. Okay, so connected in series, that is the main important point you have to keep in mind. So volt is voltage is 240, power is 60 watt, resistance we need to find out. Okay, so what is the formula? V square by R. So resistance of the lamp is 960 ohm. Okay, so when they are connected, so current also we can find out. P by V is equal to 60 by 240, 0.25 ampere. Clear? So when the lamp connected across the mains, it draws 0.25 ampere. If two such lamps are connected in series, so what will be the total resistance will be acting? 960 plus 960, R1 plus R2 is RS. So 960 plus 960 will come. 1920 That much amount of resistance will be acting. So 250 divided by that one means 0.125. So current become halved. So heat energy also I square, no? Current become half means heat energy will become I square RT. So square of current. So one half square is one fourth. So heat energy will be one fourth. Heat energy will be one fourth. So each bulb appears less bright. Since one half current only passing through it, no, each bulb, the one half of the original current only passing through it. So what is the meaning of that? Yeah. So total resistance according to that current passing through the circuit will be less. So automatically less it will bright less. Okay. Now question number 12. Two bulbs are rated 60 watt 220 volt and 60 watt 110 volt. What is the ratio of the resistance? Okay, so first case the ratio is V square by P. Second case also V square by P. So when we substitute that one, 220 square by 60 will be first case. Second case 210 square by 60. So when we take the ratio of R1 and R2, right side also we need to take the ratio. But 220 square by 60 is to 110 square by 60. So after cancellation and simplification, we will get 4 is to 1. So resistance, ratio of the resistance become 4 is to 1. Yeah. Next is question number 30. I think you all understood now how to find the ratio of the two resistances. The resistance is P square by V. V square by P. No. So that both case we need to find out and take the ratio. That's it. So simplification is like a mathematical concept, reciprocal multiplication. Two fractions division means what we will do. Denominator we will multiply as reciprocal. Okay, now question number 13. An electric bulb is rated 250 watt and 230 volt. Energy consumed in 1 hour and time in which 1.0 kilowatt hour energy when connected to 230 volt main. So first case energy consumed they are asking. So then second case time also they are asking. Okay, first case energy is P times T. So first case energy consumed in 1 hour. So time is given, energy we need to find out. Second case energy is given, time we need to find out. So anyway that formula E equal to P times T. So first case P as 250 and time is 1 hour, that is 3600 seconds. So 9 and 5 zeros. So that is 9 times 10 to the power 5 joule. Okay, now second case the energy is given 1 kilowatt hour. 1 kilowatt hour, sorry. Yeah, 1 kilowatt hour. That means 1000 watt hour. Then substituting in the formula. So power is given, energy also given, time we can find out. So since that power is like energy is like the watt hour, and the power also, sorry, time also will be in hour. So here we will get the time as 4 hours after cancellation. Okay, then question number 14. Three heaters are rated 250 watt and 100 volt are connected in parallel to a 100 volt supply. Okay, so total current, resistance of each heater, energy supplied in kilowatt hour to the three heaters in 5 hours. So power given, voltage given, current we need to find out. So P equal to V into I equal to 2.5 ampere. 250 divided by 100, no. So 2 decimal point. So 2.50, that is 2.5 ampere. Then 3 heaters means 3 times. 3 times, right? So 3 times 2.5, that is 7.5. Okay. So total current taken from the supply. So 3 heaters total. How much current? That is what we got. It's 7.5 ampere. Now resistance of each heater. So we know, I also we know for one heater how much. So we can substitute this V as 100 and I as 2.5. So R will be V by I 100 by 2.5, that is 40 ohm. Okay. Next, last one. Energy supplied to 3 heater in 5 hours. So energy is equal to power times time. Okay. So here energy is like that, 5 hours means power is 250 times 5. So 1250 watt hour. That is 1.25 kilowatt hour. Okay, so energy for 3 heaters means this is for 1 heater. How much? So for 3 heaters means multiply by 3. So 3.75 kilowatt hour. Clear? Okay, then question number 15. Total 21 questions are there. Okay, yeah, yeah. Otherwise, we can continue with the remaining problems. We will continue in another video. Okay, yeah. Thank you. Thank you for watching. May God bless you.